In this video, we'll be using trigonometry to find the missing side length of a right triangle. So just to refresh your memory, take a look at the 6 trigonometric functions. These are the 6 trig functions that we'll be evaluating and using as we go through trigonometry problems. So sine, cosine, and tangent use the acronym SOHCAHTOA. And with those, that's how you find sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and TOA is opposite over adjacent. And then basically this cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So you just flip them over to find those corresponding ones, those corresponding ratios. So let's take a look at this example on the screen. This says find the value of x for the right triangle. So what we're going to do is we're going to use our knowledge of these trig ratios to help us find a missing value. Now what I do when I start these is I note my angle. My angle here is 30 degrees. And then from there I note that I have 2 of the side lengths. I know that 8 is my hypotenuse because it's across from the square, from the right triangle symbol there. And then I know that x is my adjacent because it is next to the 30-degree angle. So I like to label these so I know kind of what to use to help me find x. So because I'm going to be finding x, I know that adjacent is going to be a part of my trigonometric function. So I can automatically eliminate sine and cosecant because those don't deal with adjacent. Now the 8 is the value that I have access to. And if I'm going to use that value, I have the hypotenuse. So if I'm going to use my adjacent and my hypotenuse, you have one of 2 choices. You can use cosine or secant. I like to use cosine because cosine I know has a button on my calculator that I can easily evaluate. So what I'm going to do here is I'm going to start with my basic here. So normally it's cosine of an angle is equal to adjacent over hypotenuse. So I have some key values that I do know for this particular equation. First, I know my adjacent is currently represented by x. So I'm going to replace adjacent with x. I also know that my hypotenuse is 8. So I can substitute that in there. And finally, I know that my angle is 30. So I'm going to substitute these values in. So I have cosine of 30 degrees is equal to adjacent, which is x, over hypotenuse, which is 8. So we're going to be able to now evaluate this for x because we only have one variable in this equation. Now there are a couple of different ways you can do this. What I like to do is set this up as a fraction is equal to a fraction, and then I can just cross multiply and solve. So I'm going to turn cosine of 30 degrees into a fraction. And then because I have fraction equals fraction, I can do numerator times denominator equals numerator times denominator. So here I have 1x is equal to cosine of 30 degrees times 8. So really all I need to do here is use my calculator and find out what cosine of 30 degrees is and then multiply that by 8. So if I look at my calculator, I have a variety of buttons on here, but one of them I notice says cos for cosine. So what I'm going to do is I'm going to type cosine 30 into my calculator and then close the parentheses. If you press enter right now, you're going to see that that's an actual number. It represents about 0.8660, etc. So that's just a number. That's why we can evaluate this as is. So I'm going to plug in cosine 30, close parenthesis, times 8. And when I do that, I find that I have an x value that is equal to 6.93. And I'm going to just round that to 2 decimal places. So I was able to use my knowledge of this trig ratio here to actually solve and find a missing side length, which is really great. Now if you did not get the same answer as me, but you plugged this directly into your calculator, double check your calculator settings. Make sure that your calculator is set to degree mode and not radian mode. If you're getting the wrong answer, please ask for help adjusting your calculator setting to make sure that it's on degree mode. But as long as you have it in degree mode, it will give you that your missing side length is 6.93 units. So let's try one more example here. So when I take a look at this, I see that I have a right triangle and I have my angle of 54 degrees. My 15 is my opposite side length because it is opposite of my angle. My y value here is my hypotenuse because it's across from the 90-degree angle. And then the x is my adjacent. Now, because I have two missing variables, we have to start by finding one variable at a time. So I'm going to start with x because that's easier, just to start with one and focus on one. So in dealing with x, what I notice is I have my angle, which is great, but then I have my adjacent side length that I need to find. So I can automatically eliminate sine and cosecant as options for what I can use to help me find x, because I need adjacent to be a part of my trig ratio. Now, when I look at the rest of this triangle, the only side length value I know for a fact is 15. So I'm not going to use cosine here because I don't know what the hypotenuse is. I need to use a value of something I know because I can only have one variable in the actual equation. So here what I'm going to do is I'm going to use the opposite and adjacent function together to help me find my missing value of x. Well, if I'm using adjacent and opposite, I know that I'm going to use tangent or cotangent. And because there's a tangent button on my calculator, that is the one that I am going to use. So here I know in general, tangent is tangent of an angle is equal to its opposite side length over its adjacent side length. So here if I fill in values, I have tangent of 54 degrees is equal to my opposite, which is 15, over my adjacent, which is x. So here I am now going to set this up like a fraction so that I can cross multiply and just use fraction equals fraction. So here I can now cross multiply, so I get 15 times 1, so 15 is equal to tangent of 54 times x. Now, remember, tangent of 54, if you plug that into your calculator, is a number. And our goal is to get x completely by itself. So we need to get x alone, and we're going to do so by dividing by tangent of 54 on each side. So x is really going to equal 15 divided by whatever tangent of 54 degrees actually is. So let's take a minute and plug that into our calculator. So here we have 15 divided by tangent of 54 degrees, close parenthesis. And what I find is that x is approximately 10.90. So that's my length for x right there. Now let's switch this around and let's focus on y. So again, I'm going to focus on one variable at a time here. I'm actually going to erase this other stuff I was writing because I'm going to now focus on y. So all I'm going to leave labeled on here is adjacent for x and opposite for 15. Now if I look at y, what I notice is that y is the hypotenuse. So I have to use something that uses the hypotenuse. So that eliminates tangent and cotangent right away. I then notice that the side length that I'm given and know is 15. So if I'm using the hypotenuse and the opposite, I know that I need to use sine. So sine of an angle is equal to opposite over hypotenuse. And you could also use cosecant here. You just don't have one of those buttons on your calculator, so sine tends to be the best bet. So now if I substitute in values, I have sine of 54 degrees is equal to 15 over y, so my opposite over my hypotenuse. Now I'm going to cross multiply here by turning that into a fraction. So if I move that down a smidge, cross multiply, I get sine of 54 times y is equal to 15. Now remember, sine of 54 is just a number. So we need to get y alone by dividing by sine of 54 on each side. So my y value is really going to equal 15 divided by sine of 54. And if I substitute that into my calculator, I end up with a hypotenuse value of 18.54 units.